Hello and welcome back. Welcome back. I'm John, an old YouTuber and PC gamer. It's Monday today, so if anyone watching this today, so have a good Monday, have a good new week. I just made a video on Dennis. 4 minutes. I made this food, but I'm ready to continue. It's 10 a.m. and I like to read about this sample language, and I did download a new copy. I need to close the doors and windows. Now it's raining. It's raining a little bit. I need to have my socks on. So I need a few minutes to get started. Yes. And I need 2 minutes to finish this Dennis video. Good. Take a little bit chill. I think take this one on too. Close here. Yes, I need 2 minutes. Yes, I need few minutes to finish this. That's a Danish video I made. Yes. Good. So, but I maybe I need to make a new read list, but not for everything, because this list is a little bit mess. My read list there That's the x86 assembly language, x86 instruction list, x86 64 I did read yesterday. This is the assembly language. That's 15. Then I will continue. I maybe should make a new read list from like here, 16, 17, 18, and then I have 18.1, 19, 20, 21, and then I got 21.123 and 111. I don't know where 22 is. Here I have 25. I don't know where 22 is. So probably I need to do this, but I like to eat this food. And this video, put this video public, and so let's eat this. So I should have waited 10 minutes to record, but I did not do that. No, I try to lose a lot of weight. That's why I eat this. Then I will eat a little bread then later, like 2 or 3 p.m. I will eat a small bread. Then I cook hot food tomorrow. I'm cooking rice and fish tomorrow. Yes, I like this Danish video. I like to put it public. Do that. I finish eating this, and then I go to my kitchen. Then put this video public. Then I will start reading. But I lost like 25 kilos. I lost like 25 kilos since last summer. Yes, don't do anything here. Let's go, continue. So I should have waited 10 minutes to record, but did not do that. Why? This is why we have this video. No, last summer, 28 July, I was 133 kilos. 133 kilos. And last month, I was 105.7. Minus 105.7. So I lost 27 kilos. I lost a lot, but I'm still like 105. I'm still too much weight. I have to go below 100 kilos. So I have to do that, not this month, but next month, end of next month, I could maybe get below 100 kilos. Not being that like 15 years. So that could be really good. Now my Danish video ready to go public. Good. Then I made 2 small videos today in Danish. And my GTA 5 online video from last night is public too, so that's 3 videos. So, but let's continue. I have to learn this, even I not understand this. A lot of stuff I don't understand because have not studied computer science on university, and I'm not computer programmer. I'm old YouTuber on pension and computer gamer, but I like to know how the computer processors is working, how the CPU is working, how a computer is working, how software is working a little bit. So this is why I do that. But probably I have to, but I just follow my read list here, I can do that. But probably I have to read something new. I already started with my Intel. That's my read list, but I made a new one here. That's my Intel, but I have to look at that later, because that will take a long time of going there. No, that's Intel, about the Intel CPUs. So I will read the Intel again and the list of Intel processors. Then I will go through whole list. I plan to do that. I could do that like every year. Every year I could read, or every second year, something like that, when I feel I need to do it again. I'm reading about the Intel CPUs, because they're adding new information. Every year they will edit this PDF. So let's get started. Yes, need a minute to go back to my bed. I have to lay my bed because I cannot sit that many hours behind my camcorder. Because then I will get back pains, because I'm still have a lot of weight. So my back have been damaged, I think, many years, because I've been like 130 kilos many years. 120 and 133 kilos have been many years. That have damaged my body, my muscles. Yes, let's continue. Read loud, activate the voice. Read to the end of documents.
Assembly language. Assembly language Motorola 6800 assembly language.png. Typical secondary output from an assembler showing original assembly language, right, 4th Motorola MC6800 and the assembled form paradigm imperative, unstructured first appeared 1949 typing discipline none. In computer programming, assembly language, or assembler language, 1, or symbolic machine code, 2, 3, is any low-level programming language with a very strong correspondence between the instructions in the language and the architecture's machine code instructions. 4. Assembly language usually has one statement per machine instruction, 1, but constants, Comments, assembler directives. 5. Symbolic labels of, for example, memory locations, registers and macros. 6. 1. Are generally also supported. Assembly code is converted into executable machine code by a utility program referred to as an assembler. The term assembler is generally attributed to Ilgsweiler and Gill in their 1951 book The Preparation of Programs for an Electronic Digital Computer. 7. Who, however, used the term to mean a program that assembles another program consisting of several sections into a single program. 8. The conversion process is referred to as assembly, as in assembling the source code. The computational step when an assembler is processing a program is called assembly time. Because assembly depends on the machine code instructions, each assembly language, NB1, is specific to a particular computer architecture. 9. Sometimes there is more than one assembler for the same architecture, and sometimes an assembler is specific to an operating system or to particular operating systems. Most assembly languages do not provide specific syntax for operating system calls, and most assembly languages, NB2, can be used universally with any operating system, as the language provides access to all the real capabilities of the processor, upon which all system call mechanisms ultimately rest. In contrast to assembly languages, most high-level programming languages are generally portable across multiple architectures but require interpreting or compiling, a much more complicated task than assembling. In the first decades of computing, it was commonplace for both systems programming and application programming to take place entirely in assembly language. While still irreplaceable for some purposes, the majority of programming is now conducted in high-level interpreted and compiled languages. In No Silver Bullet, Fred Brooks summarized the effects of the switch away from assembly language programming. Surely the most powerful stroke for software productivity, reliability, and simplicity has been the progressive use of high-level languages for programming. Most observers credit that development with at least a factor of 5 in productivity, and with concomitant gains in reliability, simplicity, and comprehensibility. 10. Today, it is typical to use small amounts of assembly language code within larger systems implemented in a high-level language, for performance reasons or to interact directly with hardware in ways unsupported by the high-level language. For instance, just under 2% of version 4.9 of the Linux kernel source code is written in assembly, more than 97% is written in C. 11. Contents. Assembly language syntax IBM System /360. Terminology. Key concepts assembler number of passes. High-level assemblers. Assembly language. Language design basic elements of code mnemonics and extended mnemonics. Data directives. Assembly directives. Macros. Support for structured programming. Use of assembly language historical perspective. Current usage. Typical applications. See also. Notes. References. Further reading. External links. Assembly language syntax. Assembly language uses a mnemonic to represent, for example, each low-level machine instruction or opcode, each directive, typically also each architectural register, flag, etc. Some of the mnemonics may be built-in and some user-defined. Many operations require one or more operands in order to form a complete instruction. Most assemblers permit named constants, registers, and labels for program and memory locations, and can calculate expressions for operands. Thus, programmers are freed from tedious repetitive calculations and assembler programs are much more readable than machine code. Depending on the architecture, these Elements may also be combined for specific instructions or addressing modes using offsets or other data as well as fixed addresses. Many assemblers offer additional mechanisms to facilitate program development.